Welcome, students, to today's lesson in support of inverse functions. In topic 1, we're talking mostly about function notation. I'm going to work number 3. Number 3 begins by saying, find g of x plus 1. So first you recognize that you're looking at the g function, so we need to know to the g function defined above. What this is asking me to do is to replace the x value in the function with the x plus 1. Therefore, g of x plus 1 will equal 2 times the new x plus 1 in place of the original x plus 4. Now I simplify this by distributing that 2. And then, last but not least, I add like terms, the 2 plus 4. The second part of this question says to evaluate f of x at this 2x plus 6 value. So now what I need to do is I need to change functions, go to my f of x function, defined above, and replace that x with the new 2x plus 6. Therefore, if I come in here to write this in function notation, this would be f of 2x plus 6, resulting in a 1/2 times the 2x plus 6 minus 2. Again, I distribute the 1/2. 1/2 times 2 is just 1x, and 1/2 of 6 is 3. And combining like terms, this results in an x plus 1. Again, that's a practice on function notation. Many times I have taught, regardless of what they put in the parentheses, it could even be the symbol of a heart. You replace the x value with that symbol. In example 3, we were replacing it with an x plus 1. Hopefully that visual might make it a little easier. Let's move down to topic 2. The more difficult examples in topic 2 are really, in my opinion, number 8 and 9, where you're adding rationals or fractions in which you must have a common denominator. Number 8, you're adding 4x plus 3 over x minus 1 to just 3, or 3 over 1. We need the 3 to have the common denominator of x minus 1. I'm going to change pen color. If I want the bottom of this to be an x minus 1, I must also multiply the top times the x minus 1. So really I'm just multiplying by something that equals 1. Let me write this again. This would be 3 times x minus 1 over 1 times x minus 1. Now that the denominators are the same, I can actually add these two fractions or collect them together over that common denominator. For sake of space, I'm going to go ahead and distribute the 3 such that this would be a 3x minus 3. Now to clean the numerator up, I would get a 7x and the denominator would be an x minus 1, and this would be your answer from adding these two fractions. You cannot cancel these x's. This numerator is one term referred to as a monomial. The denominator is two terms referred to a binomial. You can only cancel binomials with binomials or monomials with monomials. You cannot cancel parts of a binomial or parts of a trinomial. So be very careful when you're reducing these rationals. Topic 3 is questions us by asking us to solve the equation for the specific variable. Right now, looking at number 14, this one is solved for y because it says y equals. They're asking me to change it so it does not say y equals anymore, but they want me to algebraically manipulate this until it says x equals. So for sake of room, I'm going to come below y equaling the 4 minus x over 9. I'm going to replace the y with x and the x with y. When I do this, it's going to be x equaling 4 minus y over 9. I'm going to separate these somehow to distinguish that they are now very different equations. My focus is on the right side of this vertical line. I need to now solve it so it says y equals. I believe the easiest way to do this is to cross multiply. So I'm going to put the x over 1. And now when I cross multiply, I will have x times 9, which is 9x, equaling the 1 times the 4 minus y, which is 4 minus y. To solve this for y, I'm going to subtract the 4. And now I will need to divide everything by the -1 coefficient of the y, which will make this a negative 9x plus 4 equaling y. So I have solved it for y after interchanging the x and y variables. We will find in the near future that this interchanging of variables is going to produce the inverse function. Number 15 is a little different algebraically, so I'm going to go ahead and work this one also. Again, I'm asked to interchange the variables, so the y will be replaced with x, and the x will be replaced with y. Once again, I'm going to cross multiply, so I'm going to write this as an x over 1. And when I cross multiply, I'm going to get x times y plus 1, equaling 1 times y minus 2. I'm supposed to solve this equation such that it says y equals, so I must get the y out of these parentheses by distributing this x. Now, if I want my equation to say y equals, I need the y terms alone on one side of the equation. So I'm going to shift the terms around in this equation by moving the y to the left or subtracting it, and the x to the right by subtracting it. So I will result in xy minus y and a negative x minus 2. Again, the goal is for this equation to say y equals, so I'm going to factor this y out of the left side, so finally the y is almost isolated. My last step is to divide off the x minus 1. Resulting in a y equals equation, which will be y equaling your negative x minus 2 over your x minus 1. So I followed the directions, which was to interchange the variables and then to solve the equation for y. Moving to the connection to college algebra, number 1 says or asks, are these two functions f of x and g of x, are they inverses of one another? Well, to determine if they're inverses of one another, you must perform the compositions, both compositions. One composition is your f composition g, and the other is your g composition f. The goal is to see if the result of these two compositions equals x, and x only. If it equals 2x, they're not inverses. If it equals x plus 5, they're not inverses. But if it equals x, they are inverses. So this is f of g of x on the left side, which can also be rewritten as f of 6x plus 2. Now, I'm working with the f function, so I go over to where the f function is defined, and in place of the x, I put the 6x plus 2. So this becomes a negative 2 plus the new 6x plus 2 all over 6. This simplifies into 6x over 6, which is x, which is good. Remember, the goal is to see if the result is x. So I'm good on the f composition g. Now I need to do the g composition f and see if it also results in x. This would be g of f of x, which is g of the negative 2 plus x over 6. Now I'm referring to the g function. So now I go to the g function. Let me get a highlighter color that's hopefully a little nicer. Here's my g function, and in place of this x, I'm going to put that fraction. So this will become, in the g of x function, 6 times, replace the x with the negative 2 plus x over 6. Now simplify. These 6's will reduce, they're both monomials, and this does result in an x. Since both resulted in an x, then we can say yes, f of x and g of x are inverses of one another. And in general, they will rename now the g of x function with the inverse notation. Let's move down to number 3. 3 is very similar to interchanging the x and y variables and solving for y. This is how we find the inverse function. So this example is asking me to write the equation of the inverse function. Well, I can replace the function notation with y to begin with, and then I'm going to draw this vertical bar. So when I interchange the variables, taking the y, replace it with x, and the x replacing it with y, I'm creating the inverse function. I need to solve it, so it says y equals. Well, I find the easiest way to do this is to cross multiply by placing this x over 1. So now when I cross multiply, I get x times y minus 3 equaling the 1 times 4. If this equation is going to say y equals, I must get the y out of the parentheses by distributing the x. Now I need the y term alone, so I'm going to add the 3x to each side of the equation or move it to the right side. And last but not least, I divide everything by that x, so I have a y equals equation. This will be my inverse function, and this will normally be rewritten in the notation of c to the negative 1 of x, because the original function was named c of x rather than f of x. I hope this supports your college algebra class as you're continuing to learn of inverse functions. Thank you very much for watching this entire recording.